So in the case of this graph, we're going to, again, make sure it's in standard form. So I'm going to subtract 6x from both sides. So I get minus 2x squared minus 6x minus 8 is equal to 0. And then the function that goes along with this equation is minus 2x squared minus 6x minus 8 is equal to y. So that's the function I'm graphing on the right, but the equation that goes with it is on the left. And so from looking at this, I recognize right away that my leading coefficient is negative, so that a value is less than 0, which means this graph opens downwards. And the next thing I'm going to do is recognize that my vertex, because this opens downwards, is a maximum, because that would be at the top of this quadratic function, this parabola. So it's a max. And I'm going to use that to my advantage when I continue. Again, the next step is to look for the axis of symmetry. And that has an equation of x equals minus b over 2a. So my b in this case, remember I put the minus and then plug in what b is minus 6x, or minus 6, not the x. And then I have 2 times minus 2, because that's my a value. So I'm going to end up with positive 6 divided by negative 4, which is going to give me negative 3 over 2, which is also equal to negative 1.5. So I know that my axis of symmetry for this is at negative 1.5, and even though it's a decimal or a fraction, we can still use that to our advantage. So negative 1.5 is halfway between negative 2 and negative 1. Okay, so I put that dotted line. Again, the dotted line is not part of the graph. It's just a guide to recognize what's happening. Now I'm going to use my axis of symmetry to find the actual vertex. So I'm going to plug in negative 1.5 into this problem. Okay, and shouldn't be scared because it's a decimal. Decimals are numbers and they work just the same way. So I have minus 2 times negative 1.5 squared minus 6 times negative 1.5 minus 8. And that's going to be equal to my y value because, again, I'm graphing a function. And functions have x's and y's, an input and an output. So now I have negative 1.5 squared. So that's going to give me 2.25, and I'm going to multiply that by 2. So that gives me 4.5 right here. And it's a negative 4.5 because I'm multiplying it by negative 2. Then I'm going to have negative 6, times negative 1.5, which gives me a positive 9. And then I'm going to subtract 8, and it's going to give me my y. So I have a negative 4.5 and a positive 9. That gives me a positive 4.5. And I'm going to subtract 8 from that. And I get, for my y value, negative 3.5 for my y value. Which means this point that I'm graphing is at negative 1.5, comma, negative 3.5. And so negative 1.5 and negative 3.5, if I go over to negative 1.5 and I go down 3.5, which is halfway between negative 3 and negative 4, it's right here. But using this vertex, which I just found, in combination with the fact that I know the vertex is a maximum because my leading coefficient is negative, I know that my graph is going to open downwards. And since I'm trying to solve this using graphing, this tells me something. But I'm going to put one more point on there so that I can figure out. What's actually happening. So I know my y-intercept for this case is going to be negative 8. So I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8. And then since that's 1.5 away to the right, I'm going to put a mirror image point that's 1.5 away to the left, which is over here. I can graph my parabola. And just doing that, I can recognize that this parabola does not have any unique solutions. Again, a solution for a parabola is where the parabola crosses the x-axis. And so since this graph does not cross the x-axis, this quadratic function does not cross the x-axis, there aren't any solutions, which means we would have no solution. Okay? Again, the solutions are the x-intercepts. They're also called zeros or roots of this function, and there aren't any real solutions because this graph does not touch the x-axis.